This is a tutorial on how to use the SOOTHSAYER ATAK plugin from CloudRF. First of all, we'll do a quick demo and then get into how to use the settings proper. So the quickest way to use the plugin is to select a radio from the list, press the button to drop the radio upon the map, and then click the play button to model the coverage. This sends a request to the server and it shows the output of the radio. In this case, you can see the attenuation from buildings and trees to the west based upon a signal to noise ratio color schema, which is defined within the template. So now that we've done a quick demo, let's go ahead and go through the settings to work out how to use the more advanced features of this plugin, such as the automation with the co-opt feature. Open the settings in the top right corner, and here you can find the settings for all the different layers, links, co-opt and templates. The first one we need is to log in to our account. So click the account icon and log into a service. If you're using CloudRF, the service is api.cloudrf.com. If you're using a Soothsayer server, this would be the IP address of that server. Log in with your username and password and click login, and your templates will be synchronized. Once your templates have finished downloading, they will be available on your list. On this list here, we have some stock templates, which the plugin comes with just to let you play with things like drones and different radios, and also any templates created from your CloudRF account. For this demo, we're just going to use a generic UHF 450 radio with some urban clutter, so you can see attenuation from buildings and trees. So once we've selected our template, let's go ahead and add some radios. I'm placing one here and another just here. There's two radios upon the map now, and when I click this button here, it will go and model links and coverage for them. The links and the coverage are defined in the layers menu here. So we want links and coverage. And this account has a silver plan, so we can use the GPU. If you have your own server, then there's no restrictions, providing you have an NVIDIA GPU. It's really bad timing. And we can also set the resolution. We can choose from low, medium and high. Resolution determines not just the compute time, which with a GPU is fairly irrelevant, but really the file size, and that's our primary concern if we're working on an edge network, for example. So we're happy with our layer settings. Let's press the button and model the links. Links are nice and quick, so it does 2 link calls because it's bi-directional, and we can see we've got a nice clean shot there, so that link is the same in each direction. If I drag this out and introduce some obstacles, now there should be some asymmetry, so we have 16 dB from left to right and 17 dB from right to left because of the obstacles in the middle. The links use the points API, and the heat map is generated by the multi-site API. That's what uses the GPU. If we don't want the heat map, then we can just go ahead and uncheck it, because depending on your requirements, you may just want the links. So when you're doing links, it's much more responsive because you don't need to model a heat map. So we can just drag these markers around and see if we can make a little mesh network here across the river. As you can see, we've now got quite a variety of different links, and the link styling comes from the links menu here. So in the links menu, you can see the style that we're applying here, and the units are signal to noise ratio as decibels above the noise floor. We can also switch to dBm and use different units. So here we've gone to received power and a color key here. You can change these colors by selecting the color and moving the sliders. We've also prepared 2 templates, one for Manet radios and one for LP WAN. So depending on your preference, you can go ahead and define different links and colors. So now we're using the LP WAN one, and we're able to change the units. So that's manual planning and changing links. Okay, taking it up a gear, let's go and play with the new co-opt feature. That's the sheriff's badge here. Before we do that, let's go and check our settings. So we want to see coverage for these 4 call signs, which are mobile. And we have already set up our links. And finally, with the co-opt settings, we're going to remodel these because they're fast moving every 20 seconds. There's a warning here about going too fast. You can get rate limited using the public system if you go too fast. And so you can either buy your own server or reduce the interval to something more practical. If you go for just distance, then it will only send an API request when it needs to. So with the 4 call signs here, we're going to go and assign them templates using the co-opt feature. So click that button and find a list of all the markers that are on the map. Only data with an altitude above 0 will be shown. So this is a filter to make sure that we're not showing any old data that's on the map, just people with altitude, or equipment with altitude. Each of these can be assigned a template. So I'm going to assign 4 UHF radios. I'm not doing my own call sign because I'm way over in Gloucester and I don't want to see the modeling for myself. I just want these 4 in the woods. We've selected our templates and we click Start. Already we're seeing links because the links calls are nice and fast. It's going to model links for every single call sign. You have to do it this way in order to see the bi-directional links for each node. Now I can see that one of these nodes has jumped already, and now it's refreshed and it's updated to the new position. Not only are we seeing the links, but we're also seeing the heat map. So if we sit and watch this heat map, you'll see the heat map will automatically update. So now this is very powerful. We're able to see the live coverage map and the live problems. We can see where there's gaps in the coverage, but also we can see where there's opportunities, such as up here to the north. And where this becomes especially powerful is once we mix up the live picture with some planning. So I'm going to plan to extend this network by placing a radio to the north here. I don't want to be driving around and burning up fuel, testing, doing trial and error. I want to know that this is a good spot. So I'm going to use the button we used before to manually add a radio right up here. And now we've added a notional radio that doesn't exist, but we would like this to exist. On the next refresh, the links are tested. We can see already we've established 2 good links, 3 good links. So we are connected into this net, and now the coverage will be extended. And you can see that not only are we linked in, but we're actually hitting the other side of the river over there. And so we have done dynamic planning here using a real data set and a planned data set. So now let's go and use the next button, which is the polygon. So we're going to stop the automation by pressing the pause button. It's now stopped, it's frozen in time even though the data is continuing to update. Let's clear down our map, links have gone, and finally we can choose to delete the coverage layer. These coverage layers exist on your SD card as PNG images. What we're going to do now is demonstrate the polygon button here. So the polygon tool allows you to focus effort onto what really matters. So what we're going to do is place a radio here, and then we want to see coverage across in the village to the east. We don't want to see coverage all up and down the river. We're confident that there's no obstacles, so of course we're going to have a good signal up and down the river, but where it really gets interesting is here in the village. So let's go and use the polygon tool now to draw around our distant objective. So this is where we want to communicate to, and that's where our radio is. And now we can press the button, and this time the box becomes a filter. All the effort is concentrated into the box, which means we get to do very high resolution very quickly, and we don't clutter up the map with a giant circle, because we don't need to. We're not interested in a big circle, we're just interested in the village. This tool also works with the automation feature, so this heat map can update as the call signs move around. So that's the polygon bounds tool, and that is an overview of the SOOTHSAYER ATAK plugin. If you want more information, there is some limited information here in the info button with some text-only documentation, and within there there's a hyperlink to the official documentation, which is online either on CloudRF or your server, and you can also download that those docs as a PDF. This is an open source plugin, it's on GitHub. You can go and report bugs there, or you can email us and request features as well. Thank you.